right, so today we are going to look at molecular compounds. And a molecular compound is generally considered an inorganic compound, as is ionic compounds. So we break them down into these two categories here, either ionic or molecular. The last couple days we've been focusing on the ionic compounds. Ionic compounds will have alternating positive and negative ions. They do not have individual molecules. Instead, they're referred to as empirical formulas. That's like where you would have, I think it was from the 7.1 problems, you had to like N6H3 and reduce it down to N3H, indicating, since there was a, what's the math word? Lowest common multiple or least common denominator?
Lowest common denominator.
No denominator, it's not fractions. But we all know what I'm talking about, how it has a multiple in common. I don't know what the math was. LCM, yes, least common multiple. However, with molecular compounds, you cannot do this. That's no with molecular compounds. They form molecules. They share valence electrons, and the bonds will form between pairs of electrons. And so oftentimes you'll have two of the same elements combining in different ratios, and it will make a completely new compound. So we can't reduce it down because it really is a unique compound. So we're just going to focus on binary molecular compounds, so they will only have two elements in them. They will typically be between two nonmetals. And this uses prefixes in its naming in order to communicate the number of each element. So last time when we were dealing with ionic compounds, we didn't really worry about how many sodium ions were in it. We just worried about the charges. Here, we will definitely worry about how many of each element there are. So the prefixes that we will use are the monos, dis, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Are we all fairly comfortable and or familiar at least with these? You've heard them all before? Okay, lovely. So, general rules when naming molecular compounds. The first is that the less electronegative element is always listed first. There are some exceptions. Carbon is always written first. And then the other exception is that hydrogen will be written after nitrogen if they are paired together. Usually this order is a fairly good rule of thumb to follow. C will go first, and then phosphorus, followed by nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and then fluorine will be the last one. This kind of makes sense because fluorine is the most electronegative element out there. And so that follows this rule that the less electronegative element is listed first. The second rule is that the first element in the formula is written first in the name of the compound. There will be no prefix used if there is only one atom of the first element. So here's an example of a molecular compound, CO. So since there is no subscript down here, we know that there is only one carbon. To follow this rule, we would just simply write carbon. We don't put a prefix since it's one. If it were two, then you would put a prefix. Then our second element, there is only one since there is no subscript written. So we will write the prefix monoxide. Does that make sense? Okay. And then the second element is named after the first element, so we followed that. We named carbon first and then oxide or oxygen. The ending is changed to IDE, just like in ionic compounds. And then the prefix mono is always used on the second element. Again, just like we did here. If there is an A or an O at the end of a prefix, we usually drop it when naming the element begins with a vowel. That way it just flows nicer when you say it. So like monoxide, so mono has the O and so does oxide. And so we drop this O when we write it together. So that way it's just easier to pronounce. It doesn't look goofy. Does that make sense there? It's just kind of a formatting thing. So let's look at just a couple examples here before we get to working. So how would you name this molecular compound? First of all, we know it's molecular because both nitrogen and oxygen fall on the right side of that stair-step line. So we have to name it as a molecular compound. So what does N represent? Nitrogen. Do we put a prefix on it? No. So it's just nitrogen. And our second element would become monoxide. Good. What if we had disulfur dichloride? How would we write this in a formula? Sulfur, and then the little 2 because di means 2. Chloride, Cl, and then also a 2. Does that make sense? These ones are pretty simple. We don't have to worry about balancing out charges. We just have to pretty much just memorize what the prefixes mean. Okay? Make sure you are aware of these exceptions. Those would be the problems that I like to throw out there to make sure you're following your academic integrity. So please make sure you're paying attention to those.